Okay, so the module also makes this really important point. The variation we see in our data, like when we're looking at a chart or something, is often a mix of two things. The actual process changing, things genuinely varying, and our measurement system, like our tools and how we use them, having its own inherent ups and downs.
Yeah, you got it. And this is huge, especially when you're doing things like process capability analysis, which, just to clarify, is basically seeing if your process can consistently meet certain specs or requirements.
Right, right.
The module points out that a lot of times we just kind of assume that what we're seeing is just the process variation.
Hmm.
But almost always the data we're looking at is a blend of that process variation and the variation in how we're measuring it.
Okay, and I think this is where it gets really, really interesting, especially for you listening in, because it leads to this really critical question. If your process isn't performing as well as it should, it's not capable in that technical sense, how do you know if you need to fix the process itself? Or if maybe your measurement system is just throwing off the readings, making it look worse than it is? That's a real head scratcher, right?
Oh, absolutely. It's a classic dilemma. If your measurements are all over the place because your equipment's, a bit dodgy or because different people are using it differently, you might think your process is unstable when it's actually fine. You could end up wasting time and energy trying to fix something that's not broken.
Yeah, you'd be barking up the wrong tree.
Exactly. And that's where these ideas of repeatability and reproducibility come into play. They're like your detective tools.
Right. So repeatability and reproducibility, these are like techniques to help us break down that measurement variation and see what's really going on. So repeatability, the module defines it as like the inherent precision of the measurement device itself. Like if you measure the same thing over and over with the same tool, how close together are those readings?
Right. Think of it like this. Repeatability is how consistent a single tool is when the same person uses it to measure the same thing multiple times, under the same conditions. If a gauge has high repeatability, it's going to give you very similar readings each time you use it.
Okay, so like a reliable friend, you know what you're going to get.
Exactly. Dependable.
And then reproducibility is about the variation you get when different people are measuring the same thing, maybe using different tools or under slightly different conditions. It tells you how much the measurement changes because of those factors.
Exactly. Reproducibility captures the variation that creeps in when you have different operators, different people doing the measurements, even if they're following the same procedure. They might have slightly different techniques, or maybe they're using different but still acceptable measuring devices. That all contributes to reproducibility.
So the module then introduces JMP as the way to analyze this kind of data. And it even mentions a little tip that sometimes you might need to stretch the graphs in JMP to really see what's going on. What's that all about?
Yeah, JMP has some really cool visual tools to help you understand this variation. And the variability gauge chart, what it does is it lets you see the spread of measurements both within an operator, how consistent they are, and between different operators to see if there are any discrepancies there.
Ah, okay.
And that stretching tip, that's a really practical piece of advice. Because sometimes the default way the software shows you the data, it can bunch it all up, make it hard to spot little but important differences in the variability.
So you're going to zoom in and get a closer look.
Exactly.
Okay, so once you've got your gauge charts all set up and you're looking at the results, what are the key things you should be zeroing in on? The module talks about things like, seeing good agreement across measurements for each operator.
Right. So if each operator's measurements for a specific part are all really close together, that's a strong indication of good repeatability for those individuals.
Excellent.
But then the module also points out a possible warning sign, a lack of agreement on which part is actually the smallest, like is it part number 2 or part number 5? If there's disagreement there, that's a bit of a red flag.
Oh, interesting.
Yeah, if your measurement system can't consistently rank the parts in the same order, that suggests there's something iffy going on with how you're measuring in the first place. It makes it really tough to make good decisions about those parts if your measurements are that shaky.
Yeah, you're not really sure what you're looking at. And this is a great takeaway for the listening. If you're seeing that kind of inconsistency, you got to dig deeper.
Precisely. And then there's the observation about operator B, that they're showing a wider spread in their repeat measurements compared to others.
Yeah.
The module even brings up the question of whether operator B might just be less experienced, which is a really valid point. It shows how this kind of analysis can pinpoint potential training needs or, maybe inconsistencies in how people are following the standard procedures.
So it's not always about blaming the operator. It could be a training issue.
Right, exactly.
Okay, so we've spent a good chunk of time on understanding variation within measurement systems, which is super important. But the module then shifts gears and zooms out to this bigger picture idea, uncovering relationships in your data using what's called exploratory data analysis.